Let us learn the second method of balancing the redox reaction, which is called oxidation number method. This method is mainly used for molecular reactions in which all these species are given in the molecule form of molecules. No ions are involved. Let us see an example. The potassium permanganate ion, when reacted with ferrous sulfate in presence of sulfuric acid, it gets reduced to MnSO4, manganese sulfate, potassium sulfate, and it oxidizes ferrous sulfate to ferric sulfate. The reaction is given in this form and we are supposed to balance it. Now you need to know the rules. The rules are very similar to half reaction method, except that we can't add any H plus or OH minus ions in this type of reaction because no ions are involved except water molecule. We can't add anything except water molecule. This is most important to remember. So we can add only water molecule. No other molecular species can be added. Now, the balancing is always started by taking the species which is undergoing reduction and the one which is undergoing oxidation. Since the method is oxidation number, we try to find out the oxidation numbers of the main central atoms of these species, and then we try to find out how many electrons are lost or actually has been accepted by these molecular species. Let us find out in this case. In this case, manganese is in +7 oxidation state. It is getting reduced to +2. So, how many electrons it is accepting? It is accepting 5 electrons. We write it a little bit bigger one, 5 electrons. So, potassium permanganate is accepting 5 electron, getting reduced to MnSO4 minus MnSO4. On the other hand, the ferrous sulfate is having ferrous ions existing in +2 state, changing to +3. So, this is undergoing a loss of only 1 electron. Now, this is what is the net number of electrons we can have. We have to identify which species is undergoing reduction, which species is undergoing oxidation, and remember, if your redox reaction is only involving the species which are undergoing reduction and no one is undergoing oxidation, remember the equation, the reaction is wrong, or there is something wrong in this reaction, in that particular reaction. So what is the best way to understand that the reaction is correct? There is no problem in that. It is that one species will definitely be undergoing reduction, other will be undergoing oxidation. We have to find out with how many electrons it is undergoing reduction and with how many electrons it is undergoing oxidation. So it is accepting 5 electrons, it is losing 1 electron. What we do is, in order to simply balance them, we have to multiply them so that the number of electrons lost or accepted becomes the same. And this is what exactly what happens in the normally in the usual course when these species are reacted, because since it will be needing 5 electrons, there has to be 5 molecular species of ferrous sulfate so that 5 electrons are lost. So what we do is we simply multiply this by 5. What is the meaning of multiplying by 5 is that when we will rewrite this reaction, we will rewrite it in the form like KMNO4 plus 5 ferrous sulfate plus, I will put it H2SO4 similarly on this side, plus MnSO4 is written as such because we haven't multiplied this side by anything, plus 5 Fe2SO4 thrice. Okay, water will be added accordingly later on at the end. Now let's see. Here we have 5 ferrous. Here we have actually 5, but now since it is 2 here, it becomes 10. So what we will do is we'll turn it to 10. so that the Fe gets balanced. Now, Mn, Mn are already balanced. Here we also have potassium sulfate. How to balance it? Basically this method is called hit and trial. You have to now, by hit and trial, balance each and every molecular species. Like I have balanced Fe and Fe, it is balanced. Mn, Mn, it is balanced. Here we have 2 potassium. So what I will do is I will put 2 here, 2 potassium. By doing so, the manganese becomes 2, so I will put the 2 here also. So after doing all this, potassium, potassium are balanced, manganese, manganese are balanced, Fe, Fe are balanced. What is left is only your sulfate ions first now. Now let us see how many sulfate we have here. 10 and 1 here, 11 sulfate on the left hand side. How many sulfates here? 2 from here, 5 3s are 15. 15 on this, 15 and 2 makes it 17 and 1, 18. So there are 18 sulfate ions on the right hand side and there are 11 here. So what we will do is we'll simply add 7 here. So that will make 7, 10 and 7, 8 here. So that will make 10 and 8, 18. 5 3 are 15, 16, 17 and 1, 18. So sulfate are also balanced. But what is left is hydrogen and oxygen of this one. Now how many hydrogens do we have is 8 to the 16. In water molecules it will become 8. So we will put only 8 water molecules on this side. Because it is not, so you can just see here, we have added only the water molecule here. And it has been added, how many water molecules? According to the number of the hydrogens here. And by putting up here, what we find is hydrogens are balanced, oxygen 4 to the 8 are already balanced. So this is now your complete balanced equation and this is how it is balanced.